This is Professor Robert Needing, and I am going to go over some selected questions for exam review number 3 for Math 168. This will not be comprehensive through all questions, but I will cover those which I think are important. Remember that at the end of the exam review, there is a review sheet which gives all of the answers to all problems for you. For instance, let's talk about number 1. It says estimate the following areas without actually putting the numbers into a calculator. You need to label, you need to shade on a normal curve, and it identifies the normal distribution at 0, 1. All the tables are already laid out for us as far as 0 and standard deviations of 1, so we really don't have to label too many things there. On the first one, we're doing the area to the right of a z 0.25. Well, z 0.25 is barely above 1, and it shades itself to the right. By a label, that means that we should pick the value of area which is to the right-hand side. Well, remember, from the middle, 0 to the right is 50%, so there's no way we can be letter A. That area is very close to 50%. There's no way it can be 2%, and it's got to be roughly 40%. I'll use number 2 now. The area to the left of z negative 2. So I find a negative 2 z value, and my shading is to the left-hand side. Again, I use my knowledge of the curve itself. There's no possible way this is approximately 95% shading. In addition, it can't be 55% because that would be half the curve or more. It has to be letter C at approximately 2.3%. I'm going to skip to number 6. Again, we're doing the same thing here. We're doing these by hand, and we're doing them without a calculator, although it does say use a calculator for the correct area. So we will first of all get the shade, and then we'll get the correct area using the calculator. The area to the right of z at negative 0.47. So first of all, negative 0.47 is approximately here between negative 1 and 0. A little off on that, so I'm going to make it move over just a little bit. That's a little bit better. And I'm doing the area to the right. Now, if I narrow this down, I can pretty much tell you that it's got to be, it can't be letter A, and it also can't be letter D, or excuse me. Yeah, it can't be letter A, and it can't be letter D. I lost my train of thought there for a second. Now, whether it's C or whether it's B, now that makes it a little bit harder. So now I actually have to go to a calculator, and I have to get something. Remember, what we're doing here is we're finding area. And area is going to be a CDF quality. Now, I have two styles of students. I have students using a calculator and students using Desmos. I'm going to show you both, but I'm not going to show you both on every question. So on this particular one, let's say we're using a calculator, and we're doing area to the right of z negative 0.47. So I go to second, I go to distribution. Again, area is number 2 of a normal CDF. My low point here is going to be negative 0.47. That's my lower number. Remember that my upper number goes to infinity, and the number we use for that is 1. And then we use E for scientific notation, 99. That's a 1 followed by 99 zeros. Pretty darn big. Because it's a Z value, it's always 0 and it's always 1. I skip down to paste. I hit the enter button. I hit it one more time, and I get 681 or 0.681. This will be letter C when we go back to our answer grid. Letter C. Now, how do I also do that in Desmos at the same time? Well, if I'm on Desmos and I want to do the same kind of thing, I want to shade a region. Remember that in shading a region in Desmos, I open up my GUI, I go to Functions, I go to Distribution. Under Distribution, I'm doing a normal distribution. I hit the little plus sign to zoom in a little nicer. My distribution is 0, 1. So I put in a 0, I put in a comma, and I put in a 1. That's my normal distribution. I want to find CDF, probability. Remember that my lower number here is going to be negative 0.47. And you can see that the area pops up right here in the shaded area at 0.681, which is exactly the same as what we had here. I prefer Desmos, but at the same time, I understand if you already have a calculator, it works just great. Number 8 will be my last one I do here on this page. Number 8 says the area above Z at 1.1. So I'm going to go 1.11, just barely above 1. I'm going to the right-hand side. Again, when I do this, I know that I have to get area to the right-hand side. So again, I'm going to jump back, and I'm going to alternate on which one I do and which one I don't do. So I think I'll go to the calculator on this one. Second, distribution. Again, I'm looking for area. Number 2. My lower number this time is 1.11. My upper number is still positive 1E99. I'm still on a 0. I'm still on a 1. I hit paste. I hit enter. And 133. That would not round. 0.133. Letter A. Next page. I think that we'll do number 11. So what we're looking for is the area between positive and negative Z is about 99%. Well, it says use the normal distribution below to label shade, then use a calculator to calculate the endpoints. Okay, well, endpoints are not area. We are using a 0, 1, and I know that also because it's a Z, and because it's a Z, it's always on a 0, 1 for the normal distribution. So here we need to find endpoints which give us about 99% of the area. Okay, well, that's fine because we're going to have a very small amount on this tail, 0.5%, and we're going to have a very small amount on this tail, 0.5%. So there's 2 ways, again, for us to do this. When I go to my calculator, this time I'm going to be in the function of distribution, but I'm going to be in number 3, the inverse norm. I'm looking for endpoints. The area that I'm concerned with is 0.99. My 0 and my 1 become my tails. I'm looking for the center population, so I hit center on my calculator. If you don't have an updated version of the calculator, you won't have left, center, and right, and you would have to focus on the 0.5% on the left-hand side. I hit paste, I hit my numbers, and I get a 2576 when rounded, positive and negative, which is going to be letter D. If I'm doing that in Desmos, remember that what I want to do is I want to approximately have 99% under here. I'm looking for endpoints. Well, in Desmos, that's an inverse norm. So I go to functions, and I choose not the normal distribution, but I choose the inverse CDF. Inside the inverse CDF, I put the normal distribution, and the normal distribution, again, is 0, 1. I have to move outside of the parenthesis. You can see it. I have to put a comma in here, and now I have to enter the area as I'm looking for, and it's 0.99. And I have to close my values when I'm working on that particular item. And I put an area incorrectly. Sorry. In this one, I don't have the updated version in here, so I do have to do left side, and I'll show you what I mean by left side in a second. So I'm going to go with 0.05, which would be 5%. But remember, I want 0.5%, which is 0.5. A lot of students make that mistake to where they put the wrong calculation in for 0.5%. So you can see my number at 257 or 2576 when rounded. We get the same calculation as we do with the calculator. Now, why did I have to use the left-hand side notation? Because Desmos will only calculate to the left. It does the inverse of the distribution, the mu, comma, the standard deviation, comma, the left-hand area. This has to always be left tail. And I'll show you why the left tail is 0.5% kind of quickly. When I look at this normal curve, if there are 99% underneath of the curve, that means there is 1% remaining for the outside. 1% split 2 ways is 0.5% on the left and 0.5% on the right. But the decimal version of 0.5% is 0.005. That's what you saw me put into the calculator. So when I calculated, I looked at the inverse distribution going to the left-hand side of 0.5%. That gave me the 2.5 2.576 negative and 2.576 positive. Make sure you pay attention to the bottom of the sheet, and the bottom of the sheet states that you will be given these formulas on exam number 3. You can also have your formula sheet available. They will be very, very useful to you. How about number 16? Again, we're doing the area to the left of the endpoint at 25 and 3. So first of all, I'm going to take a 25, put it in the center because I'm supposed to label it. That means I have to go up to 28 plus 3, up to 31. If I went another one, I'd be at 34. Going downward, I'm going to be at 22. Take away 3 more, I'm going to be at 19. Take away 3 more, I'm going to be at 16. I'm supposed to do the area to the left of the endpoint on N25-3 curve is about 0.1. This is my area. What I'm looking for is the endpoint that associates itself with that. So it's going to be a calculator, and it's going to be an inverse value. Again, no matter which one I pick, I'm going to go to the inverse variation. In a calculator, it's number 3. The area that I'm calculating is about 0.1%, or 1%, excuse me. The distribution is not a 0 and a 1 now. The distribution is a 25. The standard deviation is 3. And it said that it was to the left of that endpoint. So I hit left, I scoot down, I hit enter, I hit my button, and 21.155. So I get my value of 21.155. Very small amount of area on the left-hand side tail. We'll do one that goes to the right. It says the area to the right of the endpoint, same kind of deal. We have a new mu and a new standard deviation, and we have an area of 0.05. So again, I'll return, and this time I'll go the other direction. And you should be able to put this in your calculator just fine. So I'll clear out what I have here. I'm doing, again, I'm finding an inverse, so I'm going to leave this alone. Normal distribution. I'm going to change that distribution 0 to 100. I'm going to change the standard deviation to 17, and I'm going to change the area to 0.05 like it told me. Now, remember, that's to the left-hand side, so see, that's a problem, right? So now we got to think about what we're doing if we're using Desmos, because this works in a calculator, but it doesn't work in Desmos, so that is a wrong number right there. So how do we calculate that? Well, again, remember, if the area to the right of my number is 0.05, then the area to the left of my number is 0.95, because the two of them have to add together to make the entire value. So if I go back into Desmos, and if there is a downfall in Desmos, it's that you can't do left, right, and change, I can find that I have 127.96. Now let's go see that in the calculator real fast just to make sure we're okay. Second, distribution, inverse norm. Now I can do the 0.05 here. And the reason I can do this 0.05 here is because I can calculate right. I scoot down to the mu value, which was 100. I scoot down to the standard deviation, which was 17. I change the acquisition to right. I hit enter. I hit one more time, and I will get the same 127.963. Whichever way you're doing it is perfectly fine. 127.963. I'm going to rifle through the true falses kind of fast, so be prepared for those. And obviously you should do all the rest of these things, but I don't think you need me to help you with them. The total area under any density curve of a decimal is 1. Absolutely true, 100%. For a normal distribution, the mean affects the spread of the distribution while the standard deviation affects the center. That is completely false. It's backwards. The shape of the normal distribution is bell-shaped and symmetrical. True, that's the definition, of a normal distribution. Letter D, the formula used to convert a value x from any normal distribution to a standard distribution is the same as the z-score formula, z equals x minus mu divided by standard deviation. True. Letter E, if we have an n on 2, 1, the distribution will be the same shape as an n0, 1, so you can see that the standard deviations are the same. The distribution is the same, but it will be shifted 2 units to the left. Oops. 2 units to the left is false. It's actually 2 units to the right. The standardized test statistic is always of the form null minus sample statistic divided by standard error. Close, but I don't think so. These two are reversed. Careful on true falses. They can be very tricky. Letter G. We can use the mean 0.25 and the standard error of 0.03 from a bell-shaped bootstrap distribution to create n of 0.03, 0.25. Well, notice that the mean here, 0.25, is not the mean here. So we have another false situation. Again, these two things are reversed. Letter H. The confidence interval formula for normal distribution is always of the form the sample statistic plus or minus z star multiplied times the standard error. True. The plus or minus z star for a 90% confidence interval for a proportion is 1.645 positive and negative. Absolutely true. All you have to do is look at your general formula sheet that you're given and that you can use on your test, and it tells you that. If you want to simply go find that on your own, then you can use the inverse norm for a 90%. Inverse norm. And put your area on center for a 90% value. And you will get the calculation of 1 plus and minus 645. Moving on to the next page, I think we'll do number 22. The following is a set of hypotheses. Some information from one or more samples from a standard error and a random distribution are provided. Find the value of the standardized test statistic z. Very good. So in number 22, first of all, we have a null hypothesis of 0.75. We have a statistic of 0.78, and we have a standard error of 0.15. Now, why did I underline those three? Because whenever we're calculating for a test statistic z, remember, z is going to be equal to the stat minus the null divided by the standard error. We just saw that back here on the true false. We just got done seeing that right here. So if we do that statistic, we're going to take 0.78, we're going to subtract 0.75, and we're going to divide by the standard error, and the standard error in this particular case is 0.015. Put that in your calculator, push all the buttons, and you're going to get 2 for a z-score. Positive 2 on the right-hand side, 2 standard deviations from the center value. We'll do number 24, same kind of thing. We'll find our values. First of all, we have an H sub O. H sub O is mu1 equals mu2. Remember that also at the same time means that mu1 minus mu2 equals 0. This H sub O is centered at 0. We have a test statistic of 78 for x1, and we have a test statistic of 72 for x2. For us, that means x bar 1 minus x bar 2, because that's our true stat, is going to be 6. In order to calculate this statistic, we would have to take 6, the test stat, minus the null, 0, divide by the standard error of the situation, and the standard error of the situation was 3.2. Again, the null is because if mu1 equals mu2, then mu1 minus mu2 is equal to 0. Your proper calculation for number 24 is 1.875 z-values. Number 25, find the p-value this time. So we're finding a p-value in this one. We have a z-score of 186. We have a left tail test. And I know that because it's a less than symbol right there. And I need to calculate the area for this. P-value always means area. Area always means normal CDF. So for number 25, we're going to go do a normal CDF calculation. We're going to go second. We're going to go vars. We're going to go number 2. Now, the lower number, because it's left tail, is negative 1 E99. The upper number is negative 1.86. It tells us that in the question. It's got to be a 0 and a 1 because it's a z-score. Anytime you see z's, it's always 0 and 1. Our calculation is 0.031. If I were inside of Desmos and I wanted to do that same calculation here, remember this is area. So I grab the function of normal distribution. I give it a 0, 1, which is, by the way, the default value. I do the cumulative probability, CDF. I let it go to negative infinity, but here I make it a negative 1.86. And you can see I get exactly the same calculation using Desmos. So for number 25, 0.031. I'm going to do number 27. In this particular one, we have z at 1.75 and we have a not equal. So we have a two-tail test happening in this particular calculation. And I'm interested in this one for one reason, because the p-value will happen on two sides. So we need this 1.75 here. Calculator says, again, we are finding area. So we go to second, we go to vars, we go to number 2. Now, in this particular one, I'm looking first of all at I'm looking at left side only right now, and I'll show you a picture in a second. Because I need this to be left side only, I do negative 1 E99. My upper number is going to be the 1.75, but it's going to be the negative version of 1.75. And I just messed that up. 1 second to backspace. Negative 1.75. I'll tell you why I'm using a negative 1.75 in 1 second. And then I know that I'm, again, on a 0 and a 1. And I'm going to show you what happens. So I get this 0.04 thing. But remember, there's another tail on the right-hand side that gives the same thing. I'll show you. Second, vars, number 2. If I did the 1.75 positive, the right side tail is the lower. And then I created a whole new upper, which would be 1 E, again, 99. So now I'm doing right tail test, all the same stuff. I'm going to get the identical 0.04. That means I need the 0.04 and I need the 0.04. I need 0.08. My normal distribution on a two-tail is always the calculation of the area times 2. My calculation is not one side of the left. Now, if you want to do that, if you're doing that in Desmos, Desmos is super fine for this particular thing. Remember, we're finding p-value. I'm on a normal distribution here. And remember, my two numbers are negative 1.75 and, got to get this other value in, 1.75. Notice that in my values of my area that I get area calculations for these particular numbers. Now, in my two-tail test, there's a couple of things we want to see. Now, remember, this is the area in between. So the area in between was not what we wanted. Remember, what we wanted was the area out here. So what I have to do is I have to say, you know what? I want this one to go to infinity negative. That's my minimum. All you do is click out, it turns into negative infinity. And let's make this one the negative so we only see the left side tail. Here it is right here, but remember you also have to double that number for the right hand side. So you have to take the 0.04 and you have to double it also. Some people like to find the center and subtract it from 1. That's okay. I'm not a fan of that one, so I'm going to skip even going over that. Number 28. In number 28, I have to read through the things. So first of all, I see a couple of things. One, I see I have a survey of 1,000 people. It asks me, what is the sample size? N equals 1,000. That's my N value. The sample statistic. All right, well, the sample statistic is right here that 43% report something. That means P hat, you never report it as a percentage, is 0.43. State the hypothesis. All right, well, look at what we're trying to prove here. What we're trying to prove is that all Americans go a week without paying cash is greater than 40%. That means that the H sub O is that the population proportion actually is 40%. H sub O. Find the test statistic. All right, well, the Z value calculation says to take the stat, 0.43, subtract the null, 0.4, divide by the standard error, which was given to be 0.16. Do those calculations and you will get 1.875. Use a calculator to find the p-value and round it to 3 decimal places. Okay, we have to do, first of all, we have to figure out where are we testing. So if we look at where we're testing at greater than. It is a right side tail test, and it's a right side tail test from 1.875 as a Z value. So no matter which one we use, we're testing area. Number 2. Our smallest number was 1.875. That was our test statistic. We're testing to the right. It's always a 0.1 because it's a Z. And when we do the calculations, we get 0.03. 0.03. I'm sure that you can get that also on Desmos. The question says, what is the conclusion of the context of the problem? Well, first of all, I have to know the significance level, and it was 5%. 0.03 is less than 0.05. Therefore, we would reject. Now, we're going to have more than that, and it's written up for you, so I'm not going to type it all in there because it would be a little intrusive for me to actually try and do that and try and fit that inside of there. However, though, you do have to include all of the words. We reject the null based on a p-value of 0.05 or 5%. We have evidence that the proportion of American adults going a week without paying cash is greater than 40%. All of those things need to be included when you're giving the response for that rejection. We're going to go to number 30. It says, a final grade in Professor Mateus's large statistics classes are approximately normally distributed, that's important, with a mean of 76 and a standard deviation of 8, and they're measured in percentiles. Provide a raw sketch. Okay. First of all, the center is 76. It's going to go up by 8 on each side, at each standard deviation. So 84, 92, 100. From 76 going down, 68, 60, and down to 52. Boom, I got it. That's all I needed for that. I'm not going to repeat that drawing over and over again, but you may need it. If Professor M's course students who earn less than 60% in the class are assigned an F. Okay, so 60% is going to get you an F. So it wants to know what proportion, that's the important word right there. That to you should mean what area, what proportion. of these students will be from the 60 mark down. So here's the 60 and downward, 60. So if we want area, it's a normal CDF calculation. We go to the calculator, we go second, we go distribution, we go number 2. Again, we have to have a small value here, -1. And it's going to be second value, E99. I'm working my way up to a larger value of 60. Now remember though, my distribution, my mu value here is 76. And my distribution is an 8. I hit enter, and it looks like approximately 0.023. If I were doing that in Desmos, again, try and share the love here. I'm looking to the left-hand side. My distribution is not 0, 1. My distribution is 76 with an 8. My minimum is -infinity, and my value is 60. Oops, hold on a second. Not -60, that's bad. My value is 60. Notice I get the same, 0.023. So the solution for this is 0.023. That is the area right here, about 2.3%. Professor M's course students who earn above a 94%. Okay, so now we're going to find that cut score of 94. And 94 was somewhere around here. I'm going to put a 94 right there. And we're looking for scores which are higher than 94. I'm only going to do it in one area this time. I think I'll do it in the Desmos this time. So I'm going to go from here. Now I want a score of 94 minimum, and I want that score to go to infinity. So I just click outside and go to infinity, and I get approximately 0.12. If I'm using a TI-84, I'm doing the area I'm taking the area up to the right-hand side by making the minimum 94. I'll write that down. I would do a normal CDF. I would do a 94, comma, I would do a 1 E99, comma, 76, comma, and an 8. And the solution for that would be 0.012. That's this area right here. That's a p-value, is really what that is. What proportion of students are in between an 82 and an 88? Okay, well, that 82 and that 88 were, let me see, the mower was 76, so that was about here. Right-hand side, 82, 88, and I'm looking for the area in there. Okay, so I'm trapping that area in the center. Back to the calculator, clear all this stuff out of my way, get my distribution happening. This is a nice one because I'm dealing with an 82. I'm dealing with an 88. I got a 76 and I got an 8. I paste that thing and it looks like about 1598, which is going to be 160. You can also do that on Desmos real quick, just by simply changing this value here to the minimum, 82, and this value here to the maximum, 88, and you get the same exact value. I like both, but I do kind of lean towards Desmos being my friend just a little bit more. So 0.160. Again, P equals. What is the 25th percentile? Okay, well, the 25th percentile means if we accumulate 25% of the area, what will be the score that's associated with this? This is an inverse norm. So when I calculate an inverse norm, remember it wants two things. It wants to know what is the area of that value. And we'll go to the calculator so we see it, and we'll do this in probably both. I get to my distribution. I go to number 3. The area is 0.25 because I want the area to the left of that to be 0.25. It's always a 0 and it's always a 1. And it's always area to the left when you're talking about percentiles. So when I do that inverse norm, of that 0.25, my inverse norm, my 25th percentile, I messed that thing up, didn't I? Give me 1 second. Going back in here, doing my distribution. I'm doing my 25th percentile, so I'm inverse norming number 3. My area was 25%, 0.25. I am on a 0. I am on a 1. I am tailing to the left-hand side because I'm scoring better than all people in the 25th percentile. And I'm pasting that number. And I'm getting a ridiculous, I'm getting a z-score. No wonder. The thing's driving me crazy here. I didn't change it because I'm in a z calculation still. Please excuse me for 1 second. Our center was not 0 and 1. Our test was 76. I was trying to figure out why I was getting a z number because I didn't punch in the right number. And our standard distribution was 8. That'll make it a little better right there. And I scoot down, and boom, I hit the button. And how about that? 70.6%. Now, how do I take care of that in the graphing calculator world? Okay, well, in graphing calculator world, remember I have to backwards this out, if you will. So clear that. Go to inverse. Just choose inverse. And then right away, choose normal distribution. Now, don't forget, and like I did the first time, and put in 76,8 to start with. Scoot over. Got a comma it again, 0.25. And here's your 70.6 right there. You see it right away. So my solution for this one is 70.6%. 70.6%. I'm going to finish this one. My calculation, if I would have finished writing this, I wouldn't have messed that up. My middle was 76, and my standard deviation was 8. And I was doing left-hand side when I was looking at. So that's just kind of like my note, so I know what I was supposed to be doing. How about number 31? Choose the graph for the area above 40. If you have a middle of 5 and a standard deviation of 48, but it's on a standard normal. None of these have these all have zeros. 0, 0, 0. So what we need here is we need a z-score. So let's get a z-score calculation by taking 40, which was the statistic right here, minusing the mu value, which was 5, right here, and dividing by the standard deviation, which was 48. Calculations on that say 0.73. Find the one that's closer to 1, but not so close to 0. You have a winner in letter C. My recommendation to you is that you do every question I did not do. You check your answers against the back. For most of them, we've done a nice job of writing out the solutions for you and how to get them. So if you were to continue on, you'll notice that most of it is typed out, most of it is written. The shading is all very nice. These are the same styles of questions you are going to see on the examination number 3. Again, it only covers chapters P5, 5.1, 5.2, or all of chapter 5 for us, in addition to P.5. If you have any questions, feel free, email me. If not, enjoy, good luck, and do well.